All right, so this is an introduction to the composition of mathematics. So we're going back and reviewing, but one of the things that drives mathematics is its structure. So we have structure in English um, that talks about how letters make up words, words, expressions, and sentences. Um, but the same thing happens in mathematics. Um, in math, factors form terms, and terms form expressions, and expressions form equations. It has the same structure, basically analogous to English. So just like letters form words and words form expressions and sentences in English, factors form terms and terms sorry, that's supposed to be form, um, expressions and equations in mathematics. So once we learn how to read mathematics, and see it's basically like a sentence structure, it'll make it a lot easier to understand why we do what we do in math. So just going back again, how do you so what is the basis of mathematics? So we have two fundamental principles of mathematics, um, and they must govern everything we do in math and algebra. So the first one is the fundamental principle of addition. So the principle of addition basically says that like terms. Now, terms we're going to discuss later, but we could say quantities here too, can be combined in any order. So again, the word combined, we want to think right now, basically means add together. All right, so we'll talk about why we say terms and combine and things like this, but this is a really important word, that the word combine is going to reflect addition. But the other thing is that it's in any order. So what's going to be nice, it doesn't matter how you combine them. It doesn't matter what order you combine things together or add things together. They just need to be alike. So this first example, you know, can you combine 7 inches, um, 7 inches with 2 inches? And since they're both inches, yeah, so we add the numbers just like we would anything else. So 7 plus 2, this would be 9 then total inches. But I can't add 7 inches and 2 feet. I can't add the 7 and 2 and get 9. I have to somehow convert them to be alike. So I know that feet, there's 12 feet, 12 inches, sorry, in a foot. So 2 feet would be 24 inches. So now that we have 7 inches and 24 inches, we can combine that. This would be a total of 31 inches. So again, we just have to be careful that we can combine only like things. So obviously, the next question says, can you combine 3 apples, 4 oranges, and 2 bananas? Well, apples, oranges, and bananas are all different. So I can't just add those numbers together. So the answer to this would be no, right? But if I classify them and change what they are, it says how much fruit do you have? Well, now can I add the numbers? Are they alike? Well, they're all fruit. So therefore, I can add them all together. That'd be 3 plus 4 plus 2, which is 9 total fruit. But I have to classify them as the same. So again, like terms, we can only add like things. So I want to do this last example. You guys already know the procedure of mathematics. Why do we add numbers the way we do? So when we add the two numbers together, don't we line up the digits vertically when we add? And why do we do that? Well, we do that because the digits define the type of number it is. So the ones digit, the 1 and the 7 represent ones. The 5 and the 0 represent tens. 2 and 4 is hundreds, and then 3 and 2 is thousands. So I can only add like things. So I can add the ones together. And if I drop it in this first column, it's still in the ones column. Now I can add the tens together. Well, 5 and 0 is just 5, but that 5 in the second column is 5 tens. 2 and 4, that's in the hundreds column, so we'd add that. But we're using this vertical format to help keep track of like digits. So again, the place value is defining what type of number it represents. So notice if we just expanded these numbers, 3,251, meaning if we wrote the digits as what they represented, this would be the expanded form of 3,251. And if we add, then the expanded form of 2,407, we would get this. So once my digits are written as their values, then do I need to write these vertically to combine? And the answer is no. As long as I search out like terms, I can combine the terms. It doesn't matter what order they're written in. It just matters that they search out and look for like terms. So here's thousands and thousands. So 3,000 and 2,000. I can combine those to get 5,000s. They're both thousands. 200 and 400. Those are like terms. They're both hundreds. So I can combine those together to get 600s. 50, well, there's only one term or one number that's a tens, and then the cons or the ones 1 and 7 would be 8. So now, of course, this would be an addition of these different numbers, and we can always combine those back together because we understand decimal points. So, of course, this is 5,658. But the idea is that as long as we can find and search out um, like terms, it really doesn't matter. We can combine in any order we want. We can still come up with the answer. So that's just an introduction. I'll be going on into the fundamental property of multiplication next to complete this introduction.